Hello everyone, welcome to Gradeup. Today we are here for the live quiz session on SOM, strength of materials. This concept is new, which is the part of the G19 revision plan that we have started. Okay, so the first quiz that happened on this concept was the quiz of fluid mechanics. We had got a very good response from our viewers. So we are continuing on this with this concept, and today we will have the live quiz on the subject of SOM. So you know the concept of live quiz. Okay, there will be few questions, 6, 7, 8 questions, which you will be given right now, right here, and you will be given 2 to 3 minutes to think upon them, to solve them, and then we will have its discussion with the proper solution. Okay, so hello to everyone, all the guys, all the students who have joined us. Okay, let some of more of the persons or the students join us, then we will begin, okay, discussing the questions. So before starting, we have got some of the comments or the queries of the students regarding the inclusion of the subject of maths and manufacturing science in the G19 revision plan. Okay, so about them, let me make it to you very clear that the maths lectures have been added. Okay, they have been added in the study plan, they have been added in the course outline, you can access them from there. And the subject of machine design is also in progress. The lectures are being uploaded on a daily basis. In a few days of time or within this week, you will get all the lectures of the subject of machine design also. And about the subject of manufacturing, let me make it to you clear that for the subject of manufacturing, we are not providing you the videos, courses or the videos in this session. Okay, due to unavailability of the resources, we are not able to provide you the video lectures, but the quizzes and the study notes are there in the Gradeup app. The link for that article, that particular article where you can get all the study notes and quizzes at one place, is given in the description box of this video. You can go there and you can study from those notes and you can practice those quizzes, because manufacturing is a kind of subject which requires a lot of theoretical understanding and lot of practice of the questions. There are nothing such called concepts in the subject of manufacturing. That is the subject which you can understand by the notes and solve the quizzes. Okay, so once again, hi to all the viewers, and let us now, I think we should start discussing the questions. Okay, so let us see what the first question is all about. The concept will remain almost similar to the live quiz of the fluid mechanics. You will be given a question, I will read it for you. You will be given 2 to 3 minutes to think over it, to solve it, and then we will have its discussion. Okay, so let us see what the first question is. The first question says, the pressure on the fluid is 3 megapascal. The Young's modulus is 210 gigapascal and the Poisson's ratio is 0.25. So the volumetric compressive strain produced is, okay, so this is an MCQ question. 4 options given, some values, some data have been given. Just take 2 minutes to think over this question and give me the answer, A, B, C or D, then I will discuss. Just take 2 minutes. Very simple question. Hi to all the viewers, try to solve the question. This time is important for the gate examination. You might all be studying hard, so we are here for this concept with the live session. Try to solve the questions. See, the pressure is given 3 megapascal. Young's modulus, what is this? This is the value of E, Young's modulus. What is the value this? This is the value of mu or 1 by m. Okay, volumetric compressive strain is asked. What is asked? Epsilon V is asked. Please, hurry up, just 2 minutes. So, what is the formula for epsilon V? That is volumetric strain. Recall it fast. Recall it. A, B. Answers have started coming. Okay, let's see. Let us see. Some might be right, some might be wrong. Let us see. Just one more minute. Just one more minute to think over it. Fast. Arnab Samant, Mohammad Saad A. Some are saying Abhishek Kumar B. Let us see. Let us see. Mohammad Sajid saying A. Just half more minute. Just half more minute. Just half more minute for this question. A is correct 100%. Mohammad Sajid is too sure. Okay, Mohammad Sajid, let us see. Let us see. Let us see. Okay, now I shall discuss it. See, this is given the value of pressure P. This will act as sigma, or basically this is the pressure in the fluid. So by the hydrostatic law, this pressure will be same, okay, on all the sides. And then using the relation between E and K, okay, E and K, E is equal to 3K 1 minus 2 mu. Mu value is given, E value is given. Find out the value of K from here. What we will get the value of K? You will get the value of K as 143 into 10 to the power 3 megapascal. This is the value of K that you are getting. Yes or no? Please try to respond me. We will take each and every question step by step. I am not going to solve it completely, but I will tell you the values that what you are getting. If you are getting the right values, then you can verify with me. This is the value of K you are getting. Yes or no? Then volumetric strain is simple. Epsilon V equal to pressure or the stress divided by K. Okay, the value of pressure is 3 megapascal. This value is 143 into 10 to the power 3. Just solve it. You will get the answer as 21.42 into 10 to the power minus 6 megapascal. The answer is, or not megapascal, this will be unitless because this is megapascal, both will cut. The answer you will get as option A. Option A. Yes, absolutely correct. Option A. I think the Gaurav Kumar is not satisfied with the concept or with the question. Okay, leave him. Yes, the question is okay. This is the kind of question, bit of a conceptual question. The pressure, the fluid in the pressure on the fluid, you can understand it is given by sigma. Okay, pressure or sigma, the stress is same because this is the hydrostatic state of stress. Okay, and hydrostatic state of stress, find out K, find out volumetric strain. The answer is 21.42 into 10 to the power minus 6. Let us see the next question. Question number 2. Let me read it. We'll give you 2 minutes time. A 5 meter long 60 mm diameter steel bar is subjected to a tensile load of 100 kilonewton. If the modulus of elasticity of the bare material is 210 gigapascal, then the modulus of resilience in Newton per mm square is okay. Just take 2 minutes. Just take 2 minutes to see to this question. The length has been given, diameter has been given, tensile load given, modulus of elasticity. Again, this is L, length, this is diameter D, this is the tensile force F, you can take it, or P you can take it, and this is the value again of E. And you have to find out the modulus of resilience. You have to find out the value of modulus of resilience. See how you will do it. Think upon something. Recall the concept of modulus of resilience. Do not fight among yourselves in the comment box. Okay, that is not the place, the right place to fight upon. We are here to get some good questions, to discuss upon some questions. So do not do that fighting in the chats. Okay, so just 2 minutes, think over it. First of all, let me give you a hint to this question. You have to find out the strain energy. Okay, and then by finding out the strain energy, dividing it by volume, you will get the modulus of resilience. Okay, find out. Okay, Shall I start? Just 1 more minute I am giving to you. Just 1 more minute to think upon this question. Just 1 more minute and then see what the answer is all about. How to solve this. Okay. See. Okay. Now I think I should answer to this question. Length is given as 5 meter. Just convert it into mm because everything has been asked in mm. So this will become 5000 mm. Okay. Diameter is given to you as 60 mm. So just find out the area of cross section from here. That will be pi by 4 into d square. Okay. Pi by 4 into d square. Finding out the value, using the value of d as 60, you will get this value of area as 2827.43 mm square. Okay. This is the value of area. Okay. Then you have to find out the strain energy. Strain energy that is given by U equal to P square L by 2AE. Okay, P square L by 2AE. P value is, what is the value of P? 100 kilonewton, but please convert it into Newton. That is 100 into 10 to the power 3 Newton. Okay, L is 5000, area is this, E value is 210 into 10 to the power 3. Because it is given in gigapascal, convert it into megapascal and use it. You will get the value of strain energy as, what you should get as 42104.5 Newton mm. Okay, Newton mm. And then finding out the modulus of resilience. The modulus of resilience, you can find it out by strain energy 42104.5 divided by 2827.43. This is area into volume will be the length divided by 5000 more. Okay, and you will get this value as 0.002978 and the unit will be Newton per mm square. All those who are getting this value, they are absolutely correct. Monica P, you are getting the answer as 2987.73. You have done something wrong with the units. Please check it. Please check it, the units. You have done something wrong with the units. The answer is this 0.02978. All those who are getting these answers, Sayuj KP, Mohammad Saad, yes, absolutely correct. Absolutely correct. Shall we move on to the next question now? 0.028, not 0.028, 0.0028 or 29. Okay, 0.0029. Let us, this kind of question will only come in the examination. Just be clear with the concepts. Okay, now let us see the next question without wasting any time. Let me read it. A concentrated load F acts on a simply supported beam of span L at a distance of L by 4 from the left support. The bending moment at the point of application of load is given by. Direct formula, half sigma into strain. Yes, you can use anything. There is nothing of that sort. You can use anything. This is just the way, one way I am telling you what is the answer, what is the method. You can use any formula. That half sigma into strain, that also comes from that part only. So this question, read the question, try to draw the diagram and then see what will be its answer. Let me draw a diagram for you. Yes, any formula you can apply. Mohammad Sajid, Abhishek Kumar, there is no problem in it. I am telling you that I was just telling you the method to solve a particular question. There can be different methods. You can apply the direct formula also, but this is the conventional approach where the direct formula you don't know. Okay. Mohammad Sajid coming with the answer D of this one. Let us see Mohammad Sajid, let others solve and let us see what is the answer to this. Let me draw the diagram for you. This will be basically the diagram for this question. This is a simply supported beam having the span as L. Okay, this total is the L. And then there is a load F that is X at a distance of L by 4 from the left support. This is F. This distance is L by 4. Okay, and this distance will be then 3L by 4. So you have to find out the bending moment at this point. This is A, this is B, this is C. So you have to find out the bending moment at point B. Now do it. Now do it. Just giving you 2 minutes to think upon this question. Simply find out the reaction first. This is the hint given to you. Just find out the reactions and then find out the bending moment at B. Most of you are getting the answer as D. Let us see. Just take 1 or 2 minutes. All of you are getting the answer as D. Maybe that is wrong, maybe that is right. Just wait a minute, we will confirm it. Let us see what the answer is. Okay. No. Okay. See, let me draw the reactions. This is R1, or let us write it as TA. Let us write this as TC or RA/RC. Okay, RA/RC. So by using the summation of forces in the vertical direction equal to 0, we get RA plus RC as equal to F. This is equation number 1. Okay, this is equation number 1. Then summation of moments at A equal to 0. Summation of moments at A equal to 0 we will do. So we will get that RC into L, this will create a anti-clockwise moment, and F into this length, this will create an clockwise moment, will be equal to F into L by 4. So from here we get the value of RC as F by 4. Okay, we get the value of RC as F by 4. So using from this equation we get the value of RA as 3F by 4. Okay, which is nothing but F minus F by 4. Okay, then we have to find out the bending moment at B. So for finding out the bending moment at B, there can be two methods. Either you do RA into L by 4 or RC into 3L by 4. Both of them will going to give you the same answer. So RA is 3F by 4 into L by 4, or RC is F by 4 into 3L by 4. Both are going to give you the same answer, that is 3FL by 16. Okay, this is also going to give you this is also going to give you the same answer. All of you who are saying the answer as D are absolutely correct. Very simple question this was. Just the application of finding the reaction and then calculating the moment at any point. Okay, I hope you all got this answer. Most of you are getting this answer correct. I am happy with that. Okay, let us see the next one. Let us see the next one. Fourth question. A thin cylindrical pressure vessel of internal diameter 800 mm and wall thickness as 10 mm is given a coating which cracks when the strain reaches to 0.0002. The internal pressure in megapascal at which cracking start in coating is. Take the value of E, that is Young's modulus, as 210 gigapascal and Poisson ratio as 0.25. This question is from the topic of thin pressure vessel. From the language only you might have recognized it, thin pressure vessel or thin cylindrical pressure vessel. So just try to use your concept. This is a very good question, I must say. Try to use the concept and find it out. What will be the answer? Just 2 minutes for each of you to think over this question and find it out. Just 2 minutes. Use the concept of strain. Try to find out that in which direction the strain will be more, or in which direction the which means in which direction it will break first. Okay, so find it out. What will be its answer? Try to calculate. Okay, find it out. 1.2, 4.2, Abhishek Kumar, Sayuj KP, 1.2, 4.2. Let us see. Just take half more minute. Take half more minute. take half more minute. Let us see. See, now I shall explain it. Longitudinal stress is given by PD by 4T and hoop stress is PD by 2T. So which is larger? Hoop stress is larger, obviously, but as soon as the stress reaches the point of longitudinal stress, the crack will start developing in the longitudinal direction. Why? Because the stress will start from 0 to, it will increase, and as soon as the stress reaches the value of longitudinal stress, there will be some cracks that will develop in the longitudinal direction. So the cracks will develop first in the longitudinal direction. So we have to consider this strain as the longitudinal strain. So longitudinal strain is nothing but sigma longitudinal by E minus this is minus mu times of sigma hoop by E. Okay, so simply if you use it, you will get the value as PD by 4TE minus mu times PD by 2TE. Okay, so just using this value, simplify it, PD by 4TE into 1 minus 2 mu. All the values have been given to you. This equates this value to 0.0002. 0.0002. Okay, just equated to 0.0002. The value of D, that is the internal diameter, has been given to you as 800. This is the value of D. Small d, capital D, whatever you call it. Let me make it small so that you don't have any confusion. Small d. Okay. This is small d. The wall thickness, this is the value of T. Okay, this is the value of T. This is the value of D. E value is this, but do not use it directly. You have to multiply it by 10 to the power 3. Then it will come in megapascal. And the mu value is 0.25. Just equate it, get the value of P in megapascal, because it is asked in megapascal. So the value of P, what you are getting? The value of P you must get is 4.2 megapascal. This is the answer to this question. Okay, this is the answer. I hope clear. Any problem in this question? No problem. So let us see next question. Question number 5. This is the question from the topic of thermal stress. Thermal stress. Let us read. Very simple question. Okay. A steel rod 10 meter long is at a temperature of 20 degrees Celsius. This is the initial temperature of 20 degrees Celsius and is heated to 60 degrees Celsius. What is the stress induced if the rod is allowed to expand by 4 mm? The Young's modulus of steel is 200 gigapascal and the coefficient of linear expansion is 12 into 10 to the power minus 6 per degree Celsius. Question is from thermal stress. Have a look at it, try to solve it. Very simple question. Just you have to use that one concept. Total deformation is equal to allowable deformation. Allowable deformation, and the total deformation will be of 2. This will be thermal plus axial compression. Just equate it to the allowable deformation, get the answer fast. We will not get much time for these kinds of questions because these are very simple questions. I am conducting the session on very simple questions on SOM this time. Why? Because the questions won't be hard. Even in the gate examination you will get very easy questions. Just try to be thorough with the concepts. Just try to be thorough with your formulas. You will get the answer. Anyone? The answer of this one, A, B, C or D? Anyone? Anyone with the answer of this one? Just 2 more minutes. Just 2 more minutes. Please make it fast. You should not take this much time on solving this kind of a simple question. Please make it fast. Okay. B. Arnab Samanta saying B. Dhanraj Karat saying A. Please Be careful, be careful. The options, the numerical values are only 2, but the options are 4. The numerical values are only 2, but the options are 4. This is what I am saying. Be careful. Be careful. A confirm. Are you sure? Are you sure? All those who are saying A, B, C, are you sure? So now let us see. See, the thermal deformation or the thermal deformation is alpha into delta T into L. The delta T in this case will be equal to 60 minus 20, which is equal to 40. Okay. So just using this, alpha value is this, delta T is 40, L value is not 10. Please remember, not 10. Its value is 10 into 10 to the power 3, because that we have to take in mm, because this side the deformation is given in mm. Okay. Okay. So this value you will get on solving as 4.8 plus delta axial compression equal to, this is 4. So the delta axial compression you will get the value as minus 0.8. Okay, minus 0.8. Then this U value you know, that is RL by AE is equal to minus 0.8. Okay. So this value is the stress. This value is the value of stress what we are looking for. The value of L you already know, 10 into 10 to the power. L is 10 into 10 to the power 3. The value of in mm. The value of E is 200 into 10 to the power 3 megapascal. Solve it. What you are getting? The value of sigma thermal is 16 megapascal, but in negative sign. Why? Because here it is already negative, and the negative sign shows that it's the compressive stress. I don't know how everyone was, means lot of you are going for A. That's why I told you that the options are only 2, means the numerical values are only 2, but it is the game of plus and minus. If the answer is in minus, you put it in plus, you will lose 0.66 marks or 0.33 marks, depending upon the whether the question is of 2 marks or 1 marks. Okay. So minus sign also, from after, if you have found out this value, this is the deformation due to thermal only. wait, let me take one or two doubts here. Abhishek Kumar is asking, if it is numerical data type question, then what should I put, 16 or minus 16? Please clear my doubt. See Abhishek Kumar, if the question is asked what is the stress induced, okay, in such kind of questions, what gate usually do, they mention it that please use minus sign for compressive stress and positive sign for tensile stress. But if nothing has been mentioned, the question has been given to you this much only, and it is asked that what is the stress induced, simply the word stress has been given, and you are getting the answer as minus 16, so you have to supply minus 16 only in the compressive stress. Okay. Okay. अभी bro reaction तो opposite होगा ना. We are not talking about the reaction. This is the sigma. This is the kind of thing, my dear. Let me explain you. Now let me explain you. See this. This is the bar. Suppose this side it is allowed to extend by 4 mm. But what is happening if the rod is not allowed to expand? Then condition remains same or differ. Wait, let me first explain you. This is 4 mm. This is the original length L, and this is the original length L, and this is the 4 mm that you are allowed to expand on increasing the temperature as delta T. But due to the thermal expansion only, you are getting an expansion of 4.8, means you have reached at this point somewhere. This is suppose 4.8. So the reaction from this side will be this only. This will be R. This will be R. Okay, this will be R. So this R by A will only give you whatever stress you are getting. Okay. Okay. If the rod is not allowed to expand, then condition remains same or differ. The condition remain always same. In that case, if this deformation you are getting will be less than 4, then there will be some kind of tensile stress. Then the direction of reaction changes automatically. You do not have to do anything on that. You just have to be careful that whether the total deformation is equal to the deformation, this deformation, that is the allowable deformation. That's it. Okay. I hope everyone's doubt is clear. Let me take one doubt from the last question. Why we not consider the hoop stress by the place of longitudinal stress? See, Amit Agrari, you are asking about the last question. See, the longitudinal stress is equal to PD by 4T, and the hoop stress is equal to PD by 2T. Okay. So what will happen when the pressure will or the stress due to pressure will increase? It will increase from 0 value, and first it will reach this value and then it will reach this value. So as soon as it has reached this value, there will be some cracks that have started develop on this section. Some cracks will develop in the longitudinal section, and then when the stress will reach the hoop stress, then the stress will develop in the hoop direction or the circumferential direction. So that's why we have considered the longitudinal, because it is smaller. Okay. I hope this is clear. Okay, everyone's doubt is clear. Okay, let us move on to the next question. Let me tell you, this is the second last question. We have total 7 questions in this session. Okay, let us read this. The bending moment in kilonewton meter of the following 5 mm thickness rectangular tube section of an alloy whose ultimate stress is 414 megapascal is. Assume the factor of safety as 3 and E as 60 gigapascal. Just take 2 minutes to solve this. Just 2 minutes, not more than that. Very easy question. Just you have to use the bending equation. Simple bending equation you have to use. Find out the bending moment. Just keep focus on the units and you will get it. You will get it. Sure. Please find it out. Just 1 more minute to do this. Very simple problem. Very simple problem. Very simple problem. Just 1 more minute. Just simply use the bending equation, find out the value of I, that is the moment of inertia, and then solve it. Very easy question, very easy question. Just keep your calculations correct and do it. And if I need to give you some more hint, find out the I about this axis. Take it this way. Chalo. Do not get confused whether to take it this way or this way. Take it along this way. Find it out. Find it out. Okay, let me tell you. See, ultimate tensile stress given as 414, factor of safety given as 3. So the bending stress will be equal to UTS by 3, that is 414 by 3. You will get this value as 138 megapascal. Simple. Okay, then simply using the bending equation, sigma B equal to my by I. Wait, what I have done this? You have to find out M. You do not have to find, you have already have sigma B, so you have to find M, that is sigma B I by Y. Simply this equation, use it, find out the value of I. I will be the I of total, that is 80 into 120 cube by 12 minus reducing the thickness, that 80 will become 5 will go this side, 5 will go this side, this will become 70 into this is 5, this is 5, so 120 will become 110 cube divided by 12. Oh sorry, this is not 120, this is 12. Okay, this is 12. So this answer you will get a very big value, 3755833.33 to the mm of 4. This is I. Y value is the maximum value, that is 120 by 2. You will get this as 60. Okay, sigma B is, you have found out, 138. So just using this formula, find out the value of m. You should get it as 8. Amit, you are getting the answer as C. Where are the options? Where are the options, my dear friend? This is a NAT problem. This is a NAT problem. Find out the value of m. You should get it as something around 8.64 kilonewton meter. Very simple problem. Okay, very simple. Just solve this. 70.7. Mohammad Saad, you are not getting the answer right. The answer is 8.64, 8.63, 8.64. That is permissible, but 70 goes beyond the range of the NAT questions that the gate provides. Any problem? Anyone having any problem in this question, or shall we move on to the last question of this session? Okay, I don't think any problem. Okay, let us see the last question. Last question is from the topic of principal stresses. Let me read it. The principal tensile stresses at a point across two perpendicular planes are 60 Newton per mm square and 30 Newton per mm square. The resultant stress and its obliquity on a plane at 20 degree with the, this is the last question, what we are doing, okay, on a plane at 25 degree with the major principal plane respectively are. Take Poisson ratio as 0.25. I am giving you 2 minutes. How to calculate I, how to choose B and D in the last question. Okay, first let me solve this one, then I will come into the last problem. Yes, we will take 2 to 3 more minutes. Yes, then I have to explain one last question also. Okay, wait. First of all, do this. See, take these values as sigma x equal, take this value, this as sigma x, this as sigma y, tau xy is 0. Tau xy is 0. Try to do 10 questions, sir. See, 10 questions become a bit lengthy. Not feasible. Because it takes out too much time, the students lose their interest. You have a lot of questions in the quizzes, in the test series, in the mocks. You can do and practice there as many questions as much you want. But here, it does not become feasible to discuss 10 or more questions. These 6, 7, 8 questions are enough. Okay? So, sigma x, sigma y. Then, theta value is 25 degree. This is the value of theta. So, you know the formula of sigma, that is 1 by 2 sigma x plus sigma y plus 1 by 2 sigma x minus sigma y cos 2 theta plus tau xy sin 2 theta. In this case, tau xy is 0. So, just find out this value of sigma, and the value of tau is minus sigma x minus sigma y sin 2 theta plus tau xy cos 2 theta. Just use the value of theta as this, sigma x this, sigma y this, tau xy this, and solve this question. You must get the value of theta as, what are you finding the value of theta? The value of theta you must get as 54.64. The value of tau as 11.49. 11.49, yes, 11.49, and this. So the resultant stress will be, because they are in perpendicular, so sigma square plus tau square root, this value you will get as 55.83 megapascal or Newton per mm square. So this is the value which you will get. 55.83 Sayuj KP, absolutely right. Absolutely right. But one more thing has been asked in this. It's obliquity. What is obliquity? Obliquity is basically, if you denote it by theta or phi, that is nothing but the angle which the resultant makes with the theta axis, or the, sigma. So this is the angle, because if this is sigma, this is tau, so this will be the resultant stress. So this becomes phi. So phi is tan inverse of theta by this. So this value, you use the value of this as 11.49, this value as 54.64, and you must get this value as 11.87 degrees. This is the obliquity. 55.6, 57.55.8 all are correct. Okay. Okay. If you're all done with this question, this was the last question. Let me explain you the previous problem, how to choose B and D. There are some who are having some problem in that. We will move on to that one. But please, first of all, finish this one. Okay. I think this is done. Now let me take you back to that last question, because some of you are having the problem. Okay. See, in this question, if you take this axis, so what you are getting, I is this one. But if you take this axis, then the I will be, what will be I? 120 into 80 cube by 12 minus 110 into 70 cube by 12. So this value will, if suppose this is x-axis and this is y-axis, so this is I-xx, this is I-yy. So I-yy will be less than I-xx in this case. If you are having some problem in understanding that how to take x and y, let me make it clear to you. See this. This is the any diagram. This is any diagram. This is any rectangular cross section. If we have to take the moment about this axis, then the axis which is parallel to this axis about which we need to take the moment, this becomes this becomes B and this becomes the D. Okay, this is B, this is D. So Ixx is simply equal to BD cube by 12. If we need to take it around this axis, this is YY. So Iyy will be equal to DB cube by 12. Whichever axis you need to take, that side you have to take at that much only, and the transverse side that you have to multiply by, means you have to take its cube. Okay. So I hope this is clear. I hope this much is clear to you. This is done. We are done with this session on the live quiz. Please comment upon the, please post your comments about how you like this session. Was this any helpful for you? Please provide us with your valuable feedback so that if you want something else we can do for you, then we will try to incorporate those things in the upcoming live quiz sessions. The concept behind giving you these kind of live quizzes or the questions live at this point of time is so that you can understand, or you can think of means you can think of the questions in a real time and solve it within a 2 and 3 minutes when you are really feeling the pressure. Okay. So why we take Ixx not Iyy? Because that is maximum, I told you. That's why we used Ixx not Iyy. Okay. Abhishek Kumar, Mohammad Arjun, all are saying thank you. So thank you. So everyone, thank you for being really patient. Again, for the manufacturing, I am clearing all your doubts. Manufacturing video courses, we are not providing the notes, the quizzes and the important topics have been given. The link has been given in the article, links have been given in the description. You can go there, find it out there, and you can really find it beneficial. You can really solve the questions from there, and you can really do great in the subject of manufacturing. Other subjects we have provided. Okay, so see you in the next session. Thank you. Bye bye.